My favorite student? Oh, it's good old Dan. This is a pretty good indication of some of the stuff you might see on the written section of your test. The test is pretty short. I think it's out of 25. I think it's got 3 written questions, and I'll give you some pretty blatant hints as to what they are. There are a couple of using principles of physics conceptual questions, and I'll give you some hints as to what those are too. And of course, as soon as I start, someone shows up late. It says a conducting wire is carrying a current towards the top of the page as shown below. Is there an external magnetic field? Is there another magnetic field on the page? Are there dots or X's? So this is not going to be the hi-fi the right-hand motor rule is really what it's called, where you're doing this one. This is going to be where you imagine holding the wire in your hand and you point your thumb in the direction of the current. Oh, wait a minute. It says due to the presence of a magnetic field. Okay, so there is an external magnetic field. I didn't draw it in the picture, but it says there is. So we are going to use the right-hand motor rule. The wire is experiencing a magnetic force directed out of the page. So if F is out of the page, how will that work? Okay, I'll use the piece of the screen behind me. I would point my thumb in the direction of the current. My palm points in the direction of the force, which would be out of the page. What direction is the magnetic field in that case? I think it is to the left. Yes? Suppose the magnetic field is changed and now the wire in question one experiences a force pushing it to the left. Okay, current would be going up. Now the force is to the left. Which way are my fingers pointing now, Aryan? Into the page. C. A stream of protons is acted upon by a magnetic force while traveling perpendicular to a magnetic field. What speed are the protons traveling at? So when we have protons and force, magnetic force is QVB. I did a quick double check. It does say perpendicular, so there will be a force, and I don't have to worry about components. I told you we could do components. I'm not going to bother. They want me to get the speed by itself. Okay. V is going to be F over QB. It's going to be 5.8 times 10 to the negative 14 divided by Q. Uh-oh. Oh, it's a proton. 1.6 times 10 to the negative 19. B, 0.6 Teslas, pretty big magnetic field. And I get 5.8 scientific notation, negative 14 divided by bracket 1.6 scientific notation, negative 19 times 0.6. I'm going to write it in scientific notation, 6.04 times 10 to the fifth. Is that right? Meters per second? If you got that 2 out of 2, otherwise I would go a half mark if I saw that, half mark for getting the V by itself, half mark for the numbers, half mark for the answer. So as far as I'm concerned, either in F equals Bill for a current carrying wire or F equals QVB for the force on a moving charge, I can give you any 3 of them, and although you can find the 4th. Fair enough. Is that fast? For a human, yes. For a proton, that's actually pretty slow. We can get them just shy of the speed of light. Get them to about 2.998 times 10 to the 8th. Ooh, this one was a little weird. Well, first thing I did was, nice try, Dueck. 0.08 meters, 0.042 meters. They gave me 2 lengths. Huh. A wire is carrying a current of 5.2 amps as shown in the above diagram. If the force that the wire experiences is that, what's the strength of the magnetic field? So like I said, I think I would start out by going FB equals Bill in this case. And I think B is going to be F divided by IL. It's clearly going to be 2.4 times 10 to the negative 2. It's pretty clearly going to be 5.2. The real question is, am I going to use the 0.042 or the 0.08? you're going to use the section that's experiencing the magnetic force. Which section is experiencing the magnetic force? The section that's in the magnetic field. I'm going to use the 0.042. 2.4 scientific notation, -2 divided by bracket 5.2 times 0.042, and I got 1 point, I guess, sorry, 1 point, I guess if I round this off, it's going to be 0.110. Units, what are the units for magnetic field strength? Teslas. Same as before, half mark for each thing. So half mark, half mark, half mark, half mark. Marcus, does that make sense why I use the 0.042 and not the 0.08? This section and this section, they're not experiencing the magnetic field. They're not feeling the force. Ooh, what's the direction? Okay. Current to the right. Magnetic field into the page. The direction is, yes, down the page. An electron, it's an electron traveling at 6.2 times 10 to the 6 meters, moves perpendicular. What's the magnitude of the force acting on the electron? You know what? This is straight plug and chug. The magnetic force is going to be QVB. It's going to be 1.6 times 10 to the negative 19. V, 6.2 times 10 to the 6. B, 8.5 times 0.0085. That's what 8.5 times 10 to the negative 3 is, but that's less typing. 1.6 times 10 to the negative 19 times 6.2 times 10 to the 6th times 0.0085. Did you all get 8.432 times 8.43 times 10 to the negative 15? Is that right? People nodding? 8.43 times 10 to the negative 15 newtons, which again seems like a very small force, but if you divide that by the mass of an electron, this electron is accelerating. Same as before, half mark for each line, so half mark. Oh, I can't even do a half mark for each line. I guess I'll do 1 mark for the answer. Ooh, what's the radius of the circle? You could drop the force down from the previous answer. I chose to do the complete derivation. I said, okay, magnetic force is what's pushing me in a circle. QVB equals mv squared over r. One of the v's cancels, and I'm going to get the r by itself. R equals mv over qb. This expression right here, I'm going to give you a blatant hint, would make a very nice using principles of physics right to explain question. I could give you a situation, for example, where the mass increases in part B, and I would say, is the radius bigger or smaller? If the particle got heavier but had the same charge and speed, would the radius be bigger or smaller? If m got bigger and nothing else changed, what would happen to r? Yeah, bigger radius, wouldn't get deflected as much. Ooh, what if I sent it faster? Would the radius get bigger or smaller or stay the same? Aiden. Yeah. Ooh, what if I bumped up the charge? Smaller. Okay. Oh, what if I bumped up the magnetic field? Smaller. So I can give you kind of mix and match questions. Oh, I might say something like, what if I doubled the mass and doubled the magnetic field? What would that do? Same. They would cancel out. This would make a very nice mix and match kind of a question. Anyways, let's crunch the numbers. It's an electron, 9.11 times 10 to the negative 31. Speed, I scrolled down. What was it, Mr. Dueck? 6.2 times 10 to the 6th. Q, 1.6 times 10 to the negative 19. B, 0.0085. Is that what it was? I went from memory. Yep. 9.11 scientific notation, -31 times 6.2 scientific notation, 6 divided by 1.6 scientific notation, negative 19 times 0.0085. Did you get a really small radius? That's only 4 millimeters. I made up some bad number. Is that right, though? Is it 4.15 times 10 to the negative 3? Yeah? No? Yes? You know what? To make the radius bigger, I think I need to have it traveling faster. I'll change the numbers next year. But 4.15 times 10 to the negative 3 meters, because 4 millimeters, that's a pretty small radius. You could measure it with instruments, but you wouldn't really notice it with the naked eye. 2 marks, I would probably go something like this. Half mark for that. You know what? Actually, I probably wouldn't give you a half mark for that. I would give you a half mark for that, half mark for the numbers, half mark for that, half mark for that. A couple of you, I think, were just dropping the force down from the previous question, which also works, because then you would have answer button equals mv squared over r. V or r would be mv squared. The squared wouldn't cancel in that case, divided by answer button, but you get the same result. Oh, just for giggles, what's the kinetic energy? I stuck this on here because I used to do a final exam when we were linear and I was trying to review whenever possible. Straight plug and chug. It's going to be a half mv squared. It's going to be 0.5, 9.11 times 10 to the negative 31. What was it? 6.2 times 10 to the 6. Don't forget the squared. Hint, if I gave you a charge's kinetic energy, could you figure out its speed if you knew its mass? And especially if it's a proton or an electron, if I give you, instead of its speed, if I give you its kinetic energy, can you figure out the speed? That might be a nice add-on to this question. Instead of giving you the speed, telling you its kinetic energy instead, right? Did you get 1.75 times 10 to the negative 17? Uh, Probably 1 mark, half mark, half mark. Ooh, now we're talking about solenoids. What's the magnetic field strength inside a solenoid of length 3.2 centimeters? Nice try, Dueck. 0.032 meters. Having 600 turns of wire. Okay. The magnetic field of a solenoid is mu naught N times I over L. Again, for this one, I have no problem giving you any 3 of the variables because mu naught's a constant. Find the 4th because there's 4 variables in here. This is going to be straight plug and chug. It's going to be 4 pi times 10 to the negative 7. Please make sure you know how to type that into your calculator. Some of you might have to type a pi times 4 times 10 to the negative 7. N 600. I 4.5. This also lends itself nicely to a using principles of physics right to explain question. I might say something like, suppose I want to double the magnetic field, or suppose I double the number of turns. Will the magnetic field be bigger, smaller, be twice as big? Suppose I make the solenoid half as long. What would happen? Twice as big. So it lends itself quite nicely to those questions. Or I could have you get one of the other variables by itself, and then as a part B, ask you what happens if we change some of the parameters. 4 pi times 10 to the negative 7, the permeability of free space. What a great name. Did you get a magnetic field of 0.106 Tesla? Fairly big. One mark, half mark, half mark. A bar magnet is free to rotate while in the magnetic field. It's initially positioned as shown. Which diagram shows the final orientation? Ooh. Well, magnetic field lines point from what to what? So that means in the external magnet, There's a big North Pole right here. There's a big South Pole right there. Oh, you know what? I think A is correct, isn't it? Because the South would get attracted to that North, and the North would get attracted to that South. Can you give yourself a lovely score, please, out of 16?